Welcome to the deep dive. So if you've been on this infrastructure as code journey, you've probably mastered the happy path, writing the code, running plan, hitting apply.
Right.
And you get to stand up this brand new digital world from scratch. It's clean, declarative. It feels great.
It really does. But that clean slate, it almost never exists in the wild. Most of the time, you're inheriting something that's already running, or your once perfect code starts throwing these weird cryptic errors.
Yeah.
And that's when you leave the basics behind and you enter what we call day 2 operations.
Exactly. And that's our mission for this deep dive. We want to give you the crucial tools for that transition. We're moving beyond just being a builder.
Right.
And equipping you with the knowledge to become an infrastructure manager. So we're going to dive into 3 core pillars: importing existing infrastructure, surgically managing the state file, and then debugging those really nasty errors.
And these are the skills that, well, they let you manage things that were never meant to be managed by Terraform. And to troubleshoot when things just refuse to cooperate. If you learn these 3, you'll be indispensable.
All right, let's start with, I think, the most common nightmare scenario.
Yeah.
You join a new company, you open up the Cloud Console, and there are 50 critical EC2 instances, maybe a dozen databases, all spun up by hand.
The dreaded ClickOps.
Exactly. They're running production, but there's zero code governing them. They're just out there in the wild.
This is the perfect use case for Terraform import. It's the command designed specifically to take those existing unmanaged resources and bring them under Terraform's control.
Now, to a lot of people, that sounds like magic.
Mm-hmm.
They think you run one command and Terraform just, scans the environment and writes 50 perfect config files for them.
And that assumption is probably the most common and dangerous misconception about import. I have to be really clear here.
Okay.
Standard Terraform import does not generate your HCL. It's not a code generator.
That distinction is absolutely critical. So if it's not writing the code for me, what do I have to do? What's the manual process here?
There's a 2-step process, and the first step is entirely on you. Before you run a thing, you have to write a hollow resource block in your .tf file.
A hollow block.
Yeah, just a stub. For one of those EC2 instances, you might just write resource off instance legacy web01. That's it. You just need to give it a type and a local name.
So I write that empty shell first, then I run the command. What does that look like?
The structure is Terraform import resource type.name unique ID.
Okay.
So for our example, it'd be Terraform import auth-instance.legacy web01, and then the actual instance ID, like I023A45C67D89. That unique ID is the key.
So when I run that, what is Terraform actually doing?
It's doing one key thing. It reaches out to your cloud provider, finds that resource by its ID, and it grabs its current state.
Everything. The instance type, the tags.
Everything. Pulls all those settings down and saves them to that address-auth-instance.legacy web01 inside your state file.
That seems like a ton of manual work. If I have to write and then fill in 50 HCL files, am I not just replacing ClickOps with, type ops? What's the real advantage?
That is a fair question. The advantage is governance. You're replacing manual, unaudited clicks with a declarative source of truth. Once that resource is in your state, you can manage its lifecycle, enforce standards, track changes in version control, all the good stuff. That is worth the initial effort.
Okay, I see the long-term game. But now the resource is imported. My state file is accurate, but my HCL code is still that hollow shell. I'm guessing I need to fill that out and fast.
You absolutely do. This is the moment of highest risk.
Why?
Because Terraform trusts the state file for what is, but it trusts your HCL for what you want.
The desired state.
Exactly. And if your HCL is empty or wrong, the very next Terraform plan will try to correct reality.
Yeah.
It might try to remove a tag you missed. Or worse, it might see a mismatch and want to destroy and recreate the whole thing.
Wow. So post-import, you're in a race to synchronize your HCL with the state before anyone else touches it.
Precisely. It requires diligent manual reconciliation. It's how you colonize existing infrastructure, but you have to be careful.
That risk you just described, that potential for drift, it really highlights how sensitive the state file is. We call it the brain of Terraform.
Yeah, or maybe like an index card catalog in an old library.
I like that.
It tells you where every book is, but it's not the actual book. And if the catalog gets messed up, well, the library is lost.
And we know you should never, ever just open up that JSON file and edit it by hand. That's a recipe for disaster.
Absolutely not. But luckily, Terraform gives us an official surgical toolkit. That's the Terraform State Command family. Let's talk about 3 of the key tools.
All right, tool 1, the quick check.
That's Terraform state list. It's your instant inventory. If you need to see every single thing Terraform is tracking right now, this command just lists them all by their address. Super simple.
Perfect. Okay, tool 2 is a lifesaver for code refactoring. Terraform state MVA, the move command.
Mm-hmm. So if I just rename a resource in my code for clarity, what's Terraform's default and terrifying assumption?
Destruction and recreation.
Right.
Let's say you have a resource called devac LV1, and you want to rename it to ingress perimeter in your code. If that's all you do, Terraform sees the old one disappear and a new one appear.
And it says, okay, time to delete V1 and build this new thing.
Which means your network traffic drops.
Yeah.
Not what you wanted. State MV stops that. It tells Terraform, hey, don't touch the real resource. Just update the name on the index card.
So you're just moving the state record from the old address to the new one.
Exactly. You can refactor your code without triggering these destructive cycles. It's incredibly useful.
It really is. Okay, tool 3, Terraform state arm. Remove. This sounds like the opposite of import.
It's the graceful exit, the forget button.
What do you mean?
When you run Terraform state arm, you're just telling Terraform, stop tracking this resource. Maybe you're handing it off to another team or some other tool is taking over. And here's the most critical question. Does state arm destroy the running server?
Absolutely not. And this is vital. State arm does not send a delete command to the cloud.
It just removes the index card.
Exactly. The resource keeps running just fine. Terraform just becomes blind to it. Future plans and applies will just ignore it completely.
That's separation of concerns. Managing the record versus managing the resource. That's a huge insight. Okay, we've covered structure and state. Now for the most frustrating part of day 2, debugging. You run Terraform apply, it hangs, and then it spits out a one-line error like operation not permitted. You have no idea where to even start.
The problem is that Terraform is quiet by default. It hides all the detailed back and forth with the cloud provider. To see what's really going on, you have to turn on the logs.
And you do that with an environment variable.
You
like
do.
Poo.
TFLRG.
Yeah.
When you enable that, you start to see the raw RPCs, the remote procedure calls. It's like listening in on the chat messages between Terraform and AWS API.
Yeah.
And often, the API gives a much better error message than Terraform shows you.
Okay, and there are different levels of logging. What are they and how do you use them effectively?
There are 5 levels, from least to most noisy: error, warn, info, debug, and trace.
So which one do I want?
For most standard issues, like a syntax error or something, setting tflog debug is usually enough. It gives you a lot of detail without just flooding your screen.
So when do I need to crank it up to 11 and use trace?
Trace is for when debug isn't enough. When you think the problem's deep inside the provider, or maybe it's some weird timing issue. Trace logs everything. Every single request, every piece of data. It's a last resort, but it's essential when you suspect a bug.
But if I turn on trace, my terminal is just going to be a massive, unreadable blur of text.
It absolutely is.
Right.
Which is why you have to save the evidence.
How?
There's a second environment variable, tflog path. You set that to a file path, and Terraform will dump all of that log output directly into a file for you.
That's the key. So once I have that giant log file, what's the best way to find the needle in that haystack?
Don't read it line by line. Use search. First, search for the resource address you were trying to build, like auth-instance.myserver.
Okay.
Second, search for HTTP status codes. Look for 403, which is permission denied, or 404, not found. A 403 in that trace log tells you instantly, oh, my INM role doesn't have the right permissions. That's the actionable detail you were missing.
So it's not a dark art, it's just knowing where to turn on the lights.
Exactly. You're just pulling back the curtain on the conversation.
We have covered so much ground here, stuff that really elevates you as an operator. Let's tie it all together.
Right. If we look at the big picture, it comes down to 3 operational disciplines.
First, importing. You have to accept the manual dance. You write the HCL code first, and import just updates the state file so Terraform can start tracking it.
And that initial sync is all on you. Second, the state file. Maintain that index card catalog with the surgical kit. Use list for inventory, MVF, to rename things without breaking them.
And Grant to stop tracking a resource without actually destroying it. And finally, debugging. You turn on the lights, use tflog, probably debug or trace, and you save the evidence with tflog path so you can calmly search for the real error.
And if you master these, you go from being a builder to a true infrastructure manager.
Absolutely.
Yeah. What's so fascinating is how much power is concentrated in that one file, the state file. It's the single source of truth for the entire history and future of your infrastructure.
Mm.
And given how sensitive it is, it raises a really important question for you as the manager. If that file were accidentally deleted or corrupted, your infrastructure would be completely unmanageable. So what essential steps must you be taking right now to ensure that file is stored remotely, locked down, and safely backed up? That vulnerability,
Yeah.
that's your responsibility now.